Okay, so let me remind you where we left off last time was considering the titration of a 100 ml solution of an aqueous weak acid, HA, that had 1 pKa, or it was monoprotic. We titrated it with a strong base, potassium hydroxide. And we solved for the initial pH before hydroxide. We also solved some buffer problems, and we sketched out this titration curve, if you remember. So the point now where we are going to solve for the pH for the first time ever is the equivalence point, where you have this steep inflection point rapidly changing pH after 1 mole equivalent of hydroxide has been added. So I'll rewrite the reaction. This titration reaction with a strong base, right, takes it to completion, or it's a one-way irreversible arrow, and it produces A minus and water. And we said one-way arrows are ICF tables. Those problems generally involve mixing 100 mils in this case with some sodium hydroxide as well. We'll solve for that volume. But the point is, when you have a one-way arrow and an ICF table, we should use units of moles or millimoles, because the molarities change and they're no longer reliable when you do a dilution or when you titrate things together. So what we should think about is how many millimoles are present. Well, for the HA, keep in mind it's 100 mils multiplied by 2 or 0.2 molar.